iconic structure you see, every metro line, every skyscraper, every bridge that connects lives rests on a silent foundation. A foundation that begins deep beneath the surface. And that's where we come in. 𝗙𝗍𝗫𝗃𝗃, smart geotechniques for better foundations.
Namaskar. My name is Sanjay Gupta. Thereafter, right from 1971, I was employed in a job and as a site engineer. Then I became a soil engineer, then senior engineer, and likewise. As a young, enthusiastic engineer with a passion in geotechnical engineering, started as an entrepreneur, founders, commonly known as FENGers, that's Foundation Engineers. FENGers is now 35 years young with a vision to make geotechnical practice as a specialist engineering services. FENGers has been instrumental in upgrading the code of practices to improve geotechnical practice in the society with an effort to match with international practices. Geotechnical engineering is a science, but it's practice and art. I always say something like, be a part of the soil, be its soul. So that is what is an achievement, and it gives me the satisfaction.
𝗙𝗍𝗫𝗃𝗃 was built on a commitment to generate authentic geotechnical data, maintaining technical integrity and a deep sense of purpose. Over 3.5 decades, we've partnered with India's most ambitious infrastructure projects, laying the groundwork, literally, working for a stronger tomorrow.
I'm Ravi Sundaram, Director of 𝗙𝗍𝗫𝗃𝗃 Pvt. At 𝗙𝗍𝗫𝗃, we are not just offering services, we are offering quality engineering. Our NABL accredited lab, our ISO certifications, our advanced testing equipment. From soil investigation to foundation testing, each step is backed by thorough and rigorous quality assurance so as to ensure the quality of data is trustworthy. Over the last 35 years, we have been building this trust with our clients and in professional circles.
Be it a metro line, a smart city, or a high-rise, our detailed, data-driven approach ensures safe, economical, and sustainable construction. It's not just about what's underground, it's about what that foundation enables above the ground. Behind every data point is a human being. Our people are the foundation of 𝗙𝗍𝗫𝗃𝗃. From seasoned engineers to young interns, every mind here is tuned to solve challenges and deliver value. We don't just work for our clients, we test today for tomorrow's progress. And as the nation progresses, we take pride in our contributions to the projects executed and humble achievements.
Hello, I'm Saurabh Gupta, Director at 𝗙𝗍𝗫𝗃𝗃 Pvt. As the market leader, we have decided to transform the geotechnical engineering industry in India and bring it to world-class standards. To do this, we have implemented a system-driven approach so we can deliver consistent quality and on-time delivery for our customers. We are the first ones to bring in latest ground technologies such as cone penetration test, pressure meter test, cross-hole seismic tests, etc. so we can unlock value and mitigate project risk. As always, smart geotechnics for better foundations.
From the surface, it's just soil. But to us, it's the beginning of possibility. 𝗙𝗍𝗫𝗃𝗃, smart geotechniques for better foundations.
Good morning, everyone. Welcome to the 𝗙𝗪𝗀 webinar series. I hope you all are doing well. And thank you for joining with us. I am Manju, Marketing Coordinator at 𝗙𝗪𝗀, and I am your host for today's webinar on Optimized Silo Foundation Design using advanced geotechnical data. This session will focus on high-resolution geotechnical investigations, particularly CPTu, which enable details, surface profiling, leading to more reliable design parameters, and optimized foundation solution for large grain silos. We are pleased to have our speaker with us today, Professor Ravi Sundaram. Professor Ravi Sundaram is the director of 𝗙𝗪𝗀 Geotechnica Private Limited with over 44 years of experience in geotechnical investigation and allied field. With this, we will begin today's webinar with Professor Ravi Sundaram. Over to you, sir.
Thank you, Manju. We welcome you all to this webinar. It's a great pleasure interacting with all of you on this webinar. We will be talking about silo foundations and how we could optimize the foundation design using advanced testing technologies. So I will be presenting on foundations of silo foundations and the role of high-resolution geotechnical investigation to optimize the foundation design of silo foundations. I would like to introduce our company 𝗙𝗪𝗀 to you. We have a very strong and vibrant team, as you can see. At a glance, we have been working on various geotechnical consultancy projects since 1990. We have a team of over 150 staff, have been doing 200 to 250 projects annually, nearly 7,000 projects completed in the Indian subcontinent. This includes Nepal, Bangladesh, etc. We have more than 15,000 customers with various having done various projects. Our activities include geotechnical investigations, geophysical surveys, laboratory testing, geotechnical consultancy, topographical and hydrological services, as well as foundation testing, as well as advanced foundation testing. What we excel is in 360-degree geotechnical solutions. So as a geotechnical investigation agency, we provide accurate data for foundation analysis. We have in-house strength and capability for foundation analysis and a very large database and experience. Now, when you go to foundation quality assurance, we review the technical specifications, foundation instrumentation, data analysis. We do site visits in various where there are various geotechnical problems, piling issues, and also we are a third-party pile testing agency. As a geotechnical consultant, we have the technical strength and experience, software capabilities, Plaxis, and various other softwares, and local presence for meetings, site visits, etc. Thank you. We were the first laboratory, geotechnical testing laboratory to get NABL accreditation. And we have a wide range of tests within our scope, both field as well as laboratory. We have a pan-India presence. We work all over the country. We have worked in the Northeast. We have worked in the South, West, Gujarat, Maharashtra, Tamil Nadu, Kerala, Andhra, Orissa. Right now we are working in Visakhapatnam. There are so many projects on which we are working. let us talk about advances in geotechnical investigations. What we have to be aware is that geotechnical investigation is not just about boreholes and SPT. Of course, you know that SPT is not all that standard because it depends on the drilling and borehole technique, the type of equipment used, the test procedure, the operator doing the test, how much energy is transferred to the SPT head, the overburden stresses, the ground conditions, various other limitations of soil sampling, transportation. There are so many other parameters which influence the results. Now, as India moves forward, a paradigm shift is required in the way we carry out geotechnical investigations. And CPTu has been at the forefront of that. Now, in the past 2 decades particularly, geotechnical practices have undergone revolutionary changes. Now, conventional boreholes with SPT, now these are being suspended with various other tests. Now, the primary one is the SPT energy measurement, so that you can standardize the SPT values to 60% energy transfer. The electric cone penetration test with pore water pressure measurement is another very important test which has been gaining currency in the country. A pressure meter test, geophysical tests, all these have really revolutionized the way geotechnical investigation is done. And electric cone penetration test, the piezo cone, is gaining popularity in the country and has been used very effectively on many projects. So for site characterization, it is very useful. So if you will look at SPT, it's applicable in most soils. Of course, gravels, it does not work. Most other tests work in all soils. A pressure meter is one test which probably can a little bit of soft rock and gravel. As far as geophysics is concerned, geophysical tests, they are applicable in all kinds of ground, including gravels and cobbles. Now, what is most important is to understand the quality of the geotechnical investigation and the quality of the data generated. If you are going to do the investigation just as a formality with a limited scope consisting of a few shallow boreholes or trial pits, have a very low budget for the investigation, it does not allow for extensive testing. Now, what you get is a poor quality data. Such an investigation is termed as a bronze level investigation. So if you will see this pyramid here, this is the geotechnical output data pyramid. This is at the lowest. So as you move up along this pyramid to the gold and platinum levels, you get much superior data. At a bronze or silver level, data is usually sketchy. Foundation design is conservative. In some situations, you could miss out important or unusual conditions, vital information. This may result in unsafe design. So my advice, don't save on the geotechnical investigation scope. It could result in unreliable foundation design and high foundation cost. Go for a gold or platinum level investigation irrespective of project size. So that can make sure that you generate good quality data and greater reliability in the foundation design, a higher factor of reliability rather than a higher factor of safety. So if you are having data which is more reliable, even lower levels of factor of safety may do. So that could result in significant savings in the foundation cost and time. So let me just give you a little bit background on the electric cone penetration test. So you have a cone which has a pore water pressure sensor, and the cone is pushed into the ground, and you measure it has a sleeve, friction sleeve, and a cone tip here with the U2 level position pore water pressure sensor. It gives you, you push it into the ground, and you are able to get the cone tip resistance, the sleeve friction, the pore water pressure. So you can interpret all these parameters very effectively and understand what is the cone resistance, and also correlate it with the various other geotechnical parameters. Now, BIS has recognized the value of this test, and IS 4968 Part 4, the draft is already under circulation, and this will contain electric cone and piezo cone penetration test. We hope it will be released soon. Of course, the ASTM code and ISO code are already available. In IS 1892, the test has been recommended as a suitable test for investigation, but the detailed procedures, IS 4968 Part 4, will be published soon. Thank you. So these are photographs of the cone, which could either be tested using anchors, or it could be on a crawler mounted CPT. The CPT rig could be mounted on a crawler. So you can see the popular types of cone available. The beneficial would be to use a cone with a 15 centimeter cross-sectional area, and the pore water sensor at U2 position just above the cone. Limitations, of course, it has a relatively high capital investment compared to conventional drilling rigs. It requires skilled operator and a person who understands computer and data acquisition. There could be limitations, particularly if you are going to push in gravel or cemented layers, you may not be able to do it. Of course, rock and boulders, you cannot. But in soils, whether it is soft clay or dense sand, you can get very good quality data. Now, it will take time for experience to build up in the country, and for designer confidence in the country. But the advantages of CPT technology far outweigh the limitations. So let's go for CPTu. What's the advantage? It's fast. So you could get very quick results, 30 meters in just half an hour to 40 minutes. You get nearly continuous data because you have electronic data acquisition. There is no error due to operator related errors. So you have enhanced data quality, simple and reliable electrical measurement, continuous readings, easy recording. It's versatile, has a wide range of spectrum of soils in which it can be done, and the geotechnical parameters that can be obtained from it. Can go quite deep. Normal soils, it could go 30-40 meters, and in soft soils, it could go up to 100 meters. It's reliable, repeatable, irrespective of who the agency is doing, which equipment is used, because the quality of data is very reliable, 0.1% of the full-scale output. You can do some discrete sampling using CPT samplers, and it can be used to get various parameters like the hydrostatic pressure, the shear wave velocity, the inclination, thermal resistivity, vision cameras, etc. These can be added as separate modules to the cone. It's safe because there are no hammers or rotating parts, clean because you don't use drilling mud, and cost effective. testing does not cost much more than boreholes. And let's look at typical timelines. You can do it quite quickly. The sample transportation to the lab is not required. Laboratory testing is not required. Compilation of data is quite fast, and foundation analysis can be done quite quickly. So you could get results very quickly. On a highway project, say with 100 boreholes, which would normally have taken 8 to 10 months, CPT can be finished in less than 2 months very quickly. Thank you. The CPTu can be used for various projects, for pre-bid and tender investigations, confirmatory geotechnical investigations, detailed ground investigation and site characterization. You could measure all parameters, including shear wave velocity. You can interpret various parameters like your N values, your density, shear. So various interpreted parameters like C, phi, gamma, OCR, constraint modulus, shear modulus, permeability. All these parameters can be used, can be determined. And ground improvement control can be done very effectively using the CPT. Now I will present to you case studies for industrial facility consisting of large grain silos, warehouse and associated facilities. The geotechnical investigation was performed in accordance with IS 1892-2021 and includes CPT in addition to boreholes and trial pits. So we were able to add value to the geotechnical investigation, enhance the reliability of the geotechnical parameters for use in foundation design. The higher safe net bearing pressure that could be justified by use of CPT is quite substantial, resulting in large savings in the foundation cost. And obviously you get what you paid for. A gold or platinum level investigation is superior and reliable. You get a very good assessment of the foundation behavior. So the first case is of a grain silo in Balrampur, Uttar Pradesh. So the scope here consisted of 2 boreholes to 30-meter depth, SPT at every 1.5-meter depth intervals, collecting undisturbed samples, measuring the SPT energy transfer to measure the what energy you're getting, and we could correct to 60% energy correction. And of course, cone penetration tests were also done. So you can look at the 2 silos here and the cone penetration test performed at this site. Yeah, so this shows you the geotechnical investigation in progress, the boreholes as well as the CPT and the data acquisition thereof. So you can see the stratigraphy as interpreted as you get from the boreholes, and also what was interpreted from these 4 CPTs. So you have a top layer up to about 10.5, 11 meters. This consists of sandy silt of low plasticity, and below that you get silty sand. Groundwater was at about a 4.2 meter depth. You can see the N values corrected for energy in the top layer up to about 3-4 meter depth. You get N values in the range of 8 to 10 at some of the locations, and particularly at the silo locations, increases to about 17, 18 in some of the other locations. Deeper soils are quite competent. Move on, please. So SPT energy was measured using the SPT energy analyzer. So what we got was an energy transfer of about 71.4%. Next, please. So the SPT energy N values were corrected for 60% energy transfer, and you can see the blue line here shows me the corrected energy corrected for 60% energy transfer. Yeah. Typical plot of one CPT, you have the cone tip resistance, sleeve friction and friction ratio, and the interpreted soil type. Move on, please. We could interpret various soil parameters like the equivalent N60. You can see the comparison with the measured N values. Fairly good comparison at shallow depths, slightly more scattered at the deeper depths. The shear strength in the top soils matched very well with the lab results. The friction angle and the bulk densities were also measured. The density values also show quite good comparison. The friction angles measured by the CPT are somewhat higher. Move on, please. And the constraint modulus, the Young's modulus, the OCR, all these parameters could be interpreted from the CPT. Move on. This is a geotechnical design profile based on this CPT. So the top half a meter is a silty sand. Below that you get clay to about 7 to 12 meter depth. And then you get the sand layers. Below 24.7 there is a thin clay layer, and then below 25.5 again you get sand. So various parameters were interpreted from the CPT. Move on, please. The E values were interpreted from the CPT. You can see the benefit of increase in the E values from the CPT correlations. So we could get much higher E values. So this is the range of, so you could get nearly up to a 40-50% increase in the E values for design, which obviously means that you're going to predict much lesser settlement. Now this is the bearing capacity analysis for a 3 meter by 3 meter size foundation and 6 meter by 6 meter size foundation, square foundations at 2 and 4 meter depth. You can see a comparison from the shear criteria at 2 meter depth. The values increase from 230 to 400 kPa. The settlement criteria, again from the CPT, the pressure increases substantially. So this represents a 74% increase in the safe bearing pressure. A similar comparison is for a 6 meter by 6 meter foundation. You get a 48% increase in the computed safe bearing pressures. For a 32 meter circular raft, you can see from the analysis that we were able to increase the SBC 100% from 110 to 220. So this meant that ground improvement was not required here. Move on, please. So this is a comparison of the values here. You can see what you get at 2 meter and 4 meter from the CPT as well as from the conventional analysis. Move on, please. This is for a 6 meter by 6 meter size raft. Again, you can see that CPT gives you much higher values. And this is for the 32 meter circular raft for the silo. This was giving me a allowable 100% increase in the SBC values. So we could use these much higher values for the design of the foundation. So there was a huge saving in the foundation cost. We could really save quite a bit. The conventional analysis was showing only 110 kPa. So ground improvement would have to be done. Also, this stone columns would have resulted in additional 2-3 months for installing the stone columns. So the CPT confirmed that stone columns are not required. Thank you. And as I told you, the saving was nearly 14,000% on the return of investment. What you could save by doing a few CPTs. The saving may be different for different projects, but on each project the saving can be substantial. Move on, please. So this is another project in Sandila, Hardoi district. So 6 grain silos adjacent to a railway track. Now additional CPT was done, and SPT energy measurement was also done here. Move on, please. So the site here is in the Indo-Gangetic alluvium, just 40 kilometers east of the Ganga River. Here you primarily get a sandy silt of low to medium plasticity, underlain by silty sand below about 18-25 meters. Groundwater was at 5 to 7 meter depth. SPT energy measurement was done, and then the CPT was done. This is typical profile showing the cone tip resistance, sleeve friction, friction ratio, and of course the pore water pressure and the SBTN, soil classification. Move on, please. So the parameters interpreted include the SPT, shear strength values, friction angle, bulk density, etc. All these parameters we could get very good match. Constraint modulus and Young's modulus, and of course the OCR gave me good comparison. So that's the design profile for the various layers. So for a 32 meter diameter raft bearing at 1 meter depth, the applied bearing pressure of 225 kPa, the CPhi analysis gave me a bearing capacity of 395, whereas the QC profile gave me 513. But settlement analysis, the conventional analysis gave me 190 mm settlement, which was not tolerable. But the CPT proved to me that you could probably go for you'll get much lesser settlements. The conventional analysis from CPT showed 118, whereas the Robertson and Cabal based analysis from CPT showed 70 mm settlement only. So this was another case where it was decided that ground improvement is not required. So you can see what the results were. So CPT based analysis showed me just 70 mm for the 32 meter raft. Move on. So the foundation settlement estimated using the conventional laboratory consolidation data is 190, but what we could get from the CPT data is much lower. And because the IES code permits up to 125 mm settlement for rafts on plastic clay, it was decided that so there was substantial saving in the foundation cost by use of CPT here. So with this, I would like to conclude this presentation. Judicious selection of CPTu in the scope of geotechnical investigation for a better and reliable assessment of safe bearing capacity can be very useful, and the cost benefits that can be reaped by performing CPTu, pressure meter, SPT energy measurement, etc. These can be enormous. CPTu, of course, provides very good quality data. In any case, that was the last slide. With this, I thank everybody for having attended this presentation.
So we'll take up. Thank you, sir. Thank you for your insightful information. We have few questions. Can we take up the questions right away?
Yes, go ahead. I think he's having network issues.
Yeah.
Go ahead.
We have a question from Samir. He is asking, sir, what are the key uncertainties that still remain even after the detailed site investigation, and how do you account for it in the design?
So I think it's about how we can minimize the level of uncertainty as much as possible. And the advantage with doing a detailed site investigation is the quality of the data that we can get from the investigation, which then feeds into our analysis and design methods and the resulting bearing pressures or foundation capacities that we obtain. So while we cannot fully eliminate all the uncertainty, we can try to minimize it to the extent possible with the help of detailed investigations.
And once you are able to get a good match between the various different types of tests that you do, you can be sure that you have minimized your uncertainties.
Thank you, sir. We have another question from Abhinav. He is asking how much hedge and center settlement considered for the silo design.
The edge and center settlement would have to be computed, and usually the edge settlement could be anything between 50 and 60% of the center settlement, but it would have to be computed by proper analysis.
Okay, thank you, sir. We have a question from Samir. He is asking what are the most critical challenges typically encountered in silo foundation design?
Because these silos are heavily loaded, 24 tons per square meter, as Dr. Vijay was telling, making sure that the settlements are within the permissible limits, that's what is critical. And mostly these silo foundations are almost at the ground surface. There's not much significant embedment. So the top soils take most of the load.
Okay, thank you, sir. We'll take up the last question right now. It is from 𝗙𝗀𝗃𝗃. He is asking, one minute. For silos of large diameter, is raft foundation design more reliably supported by CPTu based modulus or borehole based modulus?
I think based on today's presentation, we saw that the values of modulus that we get from conventional borehole-based results or using empirical correlations like balls is on the conservative side, whereas with the use of CPTu, we can get more realistic values of Young's modulus that we can use in our design. So it affects it ultimately it will affect the design of your raft foundation, and you can then be able to economize on the size of the foundation with the use of better E values from CPTu.
Thank you, sir, for your insights and for addressing the questions. With this, we conclude today's session, and I sincerely thank you to all your speakers and attending for being a part of discussion. Thank you for joining us.
Thank you, Manju. Bye-bye.
Welcome, sir.